In this nugget, we want to go ahead and provide you with some examples of data center bridging and priority flow control issues, and of course, most importantly, show you how to identify and resolve such issues. Now, the first example that we want to troubleshoot together is the fact that our virtual fiber channel interface is not online. That, of course, is the fiber channel over Ethernet interface. Bunch of possible causes here, and I've listed them for you. The first is that your fiber channel over Ethernet attached server has no connectivity to fiber channel or to your fiber channel over Ethernet attached storage. So show interface for the virtual fiber channel interface that's mapped to this server would reveal that your status is down. We want to verify our configuration using show running config here. The default setting for our virtual fiber channel is shut down. So we want to make sure that the virtual fiber channel interface is indeed enabled. Now, we can use the show LLDP interface command to ensure that link layer discovery protocol, transmit, and receive are enabled on the interface and that our peer supports LLDP. If LLDP is disabled, the virtual fiber channel will not come online. You can enable LLDP transmit and receive by using the LLDP interface subcommand. If the show LLDP interface command indicates that the peer might not support LLDP, then obviously check the peer to determine whether it supports data center bridging exchange. We can use the command show system internal DCBX info interface in order to verify this. So I can't emphasize it enough how important this verification command is of show system internal DCBX info interface, and then here I'm specifying the Ethernet 1/2 interface as an example. In the output from this command, you want to check the peer's LLDP values and look for any errors. Also, check the peer data center bridging exchange TLVs. Make sure that the PFC and fiber channel over Ethernet TLV were negotiated as willing and enabled and that no errors exist. What we can often run into is that the DCBX, the data center bridging exchange feature, isn't working because our peer doesn't support LLDP, or they don't support data center bridging exchange, or they don't support some of our TLVs. Or we could have unexpected data center bridging exchange negotiation results that have occurred. If the data center bridging exchange feature is not supported, an option exists to force PFC mode on the interface. So we would use the interface command to enter interface configuration mode, and then we would use the command priority flow control mode, and then go ahead and issue your context-sensitive help. Notice there will be an on option in order to force the priority flow control mode. Now, a frequent problem we see on the Cisco Nexus 5548 is that the class fiber channel over Ethernet system class is not enabled in the QoS configuration. Remember, before enabling fiber channel over Ethernet, you must include the class fiber channel over Ethernet in each of the policy types. That's network -QoS. That's the queuing policy. And finally, the QoS policy. So let's make sure that class-FCOE is indeed enabled in each of those three policy types. We can use the show run in order to verify this. Now, we might see a situation where we're receiving constant pause frames when the switch interface is connected to the converged network adapter. If the Cisco Nexus 5000 series switch is connected to a CNA along with slow servers that are unable to process the traffic from the switch port, then the server is going to send X-off pause frames to the switch to slow it down. This increments the pause counters when using the show interface Ethernet command. First, we got to verify that this is actually happening. So for a few iterations, go ahead and utilize the show interface Ethernet pipe grep-I pause command and ensure that the pause frame count is incrementing. Or you could use the show interface Ethernet priority flow control command and ensure that the PFC frame count is incrementing. Also, the show queuing interface Ethernet command, and you can check the pause status. If the receive, active, and pause counts increment, then the issue is probably caused by X-off frames that are received from the server. We should definitely consider investigating the slot of the appropriate server to ensure that it's high speed. We got to make sure that we're utilizing servers that can run at a consistent 10 gig throughput. Now, realize that your switch ports can become error disabled because of the high rate of pause frames that they have received. The port usually goes into an error disabled state because of pause frames only when the drain rate is less than 5 megabits per second on a 10 gig port. This rate means that the server is slow and is sending many pause frames to the switch ports. You can verify this situation, of course, with show interface brief. Now, of course, you can use pause error disable recovery to get the ports out of this state. So in this nugget, we took a look at a couple of classic situations that could go wrong related to data center bridging exchange and pause frame behavior. Please keep in mind that we saw some very valuable troubleshooting commands in this particular nugget that you should be committing to memory, especially if you're interested in Cisco certification. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.